Hello everybody and welcome to the class. Welcome to Psych 308, Statistics for Psychologists. I gotta admit that as someone who teaches statistics, it is very hard for me to say statistics, usually because I talk a little bit faster than what my mouth wants me to. But anyways, so I may just call it stats. At any rate, thank you so much for being here and congratulations. If you are here, that means you have conquered Psych 219, which is Research Methods 1, and I know how much people love that class. So congratulations on that. Let's go ahead and get right into it. Now, I will tell you that Chapter 1 is going to be a little bit different. Actually, the first couple of chapters are going to be formatted a little bit different than the later chapters. As I mentioned at the beginning of the semester, we're generally going to kind of have basically the first, you're going to have usually three video lectures for each chapter. The first is going to be usually kind of talking about the theory about the stats, and the second video will be applying those stats, and then the third video will be how to do that in a statistical software like JASP. But because this chapter is so early on, we're not actually calculating anything yet, and so this chapter and chapter 2 and maybe a little bit of chapter 3, we're not really going to be calculating anything. We're not going to be like crunching numbers. We're just going to be laying down the foundation for statistics. So I know that sounds really, really exciting, but let's jump right into it. So what I want to talk a little bit about is what statistics are. So we've talked about this a little bit by now when I was introducing the class at the beginning of the semester. But basically, statistics are all about data, right? So it's all about interpreting data, organizing data, collecting it, analyzing it, and presenting it. So what are data? Data are going to be any kind of ways that information are conveyed or represented. Usually that means in a numerical form. And in fact, for our class, for our course this semester, it's going to be almost always by numerical form. Not all, not 100%, but in this class it is going to be pretty close to 100%. So data are going to be any kind of human behavior then that we can turn into a number to help us analyze, to help us draw conclusions about. So that is data. And as I mentioned, that there are kind of two sides to this. Or at least I think of two sides of this. One is that we are going to be doing stats, and we're also going to be understanding or evaluating stats, which means that usually for the first half of a chapter, we're going to be talking about understanding the stats, and the second half is going to be doing the stats. So in that way, it's a lot like any other kind of language that you try to learn. That with the language, you can comprehend it, but then you have to also produce it. Right? For me, I feel pretty good about reading Spanish, but I do not feel very good about writing Spanish. So we have to practice on both of these for stats. The other thing that I want to point out in terms of its similarity with language is that languages take a long time to learn, right? It's not like a language can be picked up in an afternoon, and they involve practice. They involve you actually trying it out and saying it and reading it yourself. And statistics is not that different from that either. Even if you are a math whiz, if you're looking at a lot of these equations and looking at these models, they're only going to get you so far until you start having to practice and use those things yourself. So we're going to be trying to use a lot of examples this semester so that way we can get good at speaking and understanding this language. So there are two types of statistics. The first half is going to be what's called descriptive statistics. This is what's going to be roughly the first half of the semester, maybe the first third of the semester actually, is going to be describing and summarizing and organizing data. That is descriptive stats. An example of descriptive statistics would be like saying, how many people are in this class? Okay, it's 20 or 25. Wow, that was really easy, right? But we might, try to describe something else, such as what is the most used social media platform in Massachusetts? There are lots of different ways to answer that. We could say that, well, overall, it's Facebook. But if I were to ask our classroom, is it Facebook? The answer is going to be no, because usually it's going to be something a little bit more modern, like TikTok or Instagram or something like that. And so you can even see here already that we have to be careful about the way that we phrase things, because what we're trying to do may be different depending on the question. This question right here about what is the most used social media platform in Massachusetts means that we're going to be drawing a sample size from Massachusetts, and we're going to try to cover every social economic status, every age range, every ethnicity, every religion, every public versus private education, college versus high school education. You get the idea that we'd want to look at everything, not just the people that are in this class. But in doing so, we would be describing the broad trends of what we find, and that's what makes it descriptive. Inferential is much more complicated in my opinion. That's why we're saving it for the second half of our course this semester. So inferential statistics is all about testing data for its meaning. So thinking about what are the trends and what will be the trends. So forecasting, for example, is an example of inferential stats. Or if I wanted to, for example, give a poll in our class to look at what kind of trends are there among people who take morning classes. Are they introverted or extroverted? Do they drink coffee or do they not drink coffee? Do they get 8 hours of sleep or do they get 4 hours of sleep? If I'm doing that and I'm polling our class, but I'm trying to make a broader generalization about the rest of America, that would be inferential statistics, because I'm taking some data and I'm trying to apply it to the broader image. Another example would be, has social media preferences changed over time? In order to do that, I would need to look at the trends and try to understand and interpret what those trends mean and where they are going. So those are the two branches. We have descriptive and inferential statistics. Now, the big picture is that if you're in this class, you are maybe not so much interested in statistics, but you're very interested in human behavior. At least I hope that you're interested in human behavior because you're in psychology. However, I will say, my background, as some of you know, my background is actually with non-human animals. I have a PhD in psychology, but my thesis is all about non-human species and how they develop abstract concepts and how they remember things and how they visually process information. So maybe if you don't love humans, that's okay. I kind of get it. But for most of us, we are interested in how humans behave. And so a lot of the examples that we're going to be giving this semester are going to be human-specific, that are going to be looking at human behavior and things like that. But here's the problem, is that if we are interested in humans, we can't measure or observe every single person in the world. It would just be impossible, right? It would require too much time, too much money, too many resources to do. We can't even ask everybody in Massachusetts what their favorite social media platform is, right? It would be too expensive to try to track down every single person to ask them and then to make them comply with it. So we can't measure every single person. Instead, what we need to do is we need to maybe study a group of people and try to generalize or extrapolate those findings to a bigger picture. And when we do that, we're going to be talking about that in terms of samples and populations. So the small group, that is the sample. The sample we hope represents the population. So another way to think about this is that the population is everybody who could be included in this research question. So for example, if we're talking about what are the most popular platforms of social media in Massachusetts, then everybody in Massachusetts is the population. But if we only poll or question 100 people about that 100 people is going to be our sample. So the population is going to be everybody or everything that could possibly be a data point for this research. But again, that's not super feasible. Instead, what we want to do is we want to study a sample and then draw conclusions to the population based on that. Now, as you remember from Research Methods 1, that's usually much easier said than done, right? Because it's really hard to find a representative sample. If I was to try to find a representative sample for Massachusetts, I would need to make sure that I have people not just from Western Mass, but also people from Boston and people from North and South Massachusetts. I would need to make sure that I'm looking at children, but also looking at the elderly. I would need to make sure that I'm looking at people with high school educations and people with college level educations, and so on and so forth. So the sample is going to be the data that I acquire from that, and the population is going to be and the sample is going to be a subset, a smaller part of that population. So here's kind of a graphical representation of this, where we have a population, which is a lot of people, and then we're going to choose a certain number of those people to represent them. That is going to be the sample. Now, one of the things you really got to be careful about is making sure the sample is indeed reflective of the population. It can be very easy, for example, for me to just ask the people in our class, what are your favorite social media platforms, and then try to draw conclusions to the rest of the population, but we know that that would not be good, right? Why would that not be good? It would not be good because y'all are, generally speaking, younger than most other people in Massachusetts, which means that y'all are going to skew more towards the younger platforms like TikTok or even, I guess, is Instagram considered like a young social media platform? I feel like if I use it, it can't be that young, right? But you get the idea. We want to make sure this sample is very diverse. And we're not going to be talking too much about how to make that happen because you already learned about that in Research Methods 1, and it's also something that you're going to go on to do in Research Methods 2 as well. So this isn't always the case in science, and this is one of the things that I want you to kind of be skeptical about anytime you read a scientific article. I want you to think about, what is the sample? Is it reflective of the population? Usually not. And the reason why it's usually not is because people who do research generally do research on the people that are in college. So a lot of psychological research takes place on college students, which are not always reflective of the greater population of the USA or even of the world. All right, again, I don't want to go into too much detail about this because we're not going to be collecting samples that much on our own this semester. A lot of cases we're going to be given a sample, so we'll be given the data. But as I mentioned, you want to make sure that your sample has the same characteristics as the broader population that you are trying to represent, and the more the better. Usually the bigger the sample, the better. However, there are limitations there because usually the bigger the sample, the more it costs to do that study, the longer it takes to do that study, and the more people you need to help you collect that data. So most statisticians are going to be using lots of different ways to randomly sample people in order to try to achieve that broad, diverse sample that we aim for. So there are several different ways of doing that. Simple random samples are generally the best, but they're hard to do because it means that every single person in that population is just as likely to be selected as the next person. But again, that's hard to do. Even when you see this done in politics, for example, in politics, they oftentimes rely on cold calls, right? So they call up random phones hoping that people will pick up the phone and talk to them. And what they find is that that is not a very good representation of the population. Why? Because generally speaking, older Americans will pick up the phone, whereas newer Americans will not pick up the phone. And I say this as somebody, and I'm not a young American really, but like if I see somebody calling, if my dad is calling me on my phone, my first thought is, can't he just do this in a text message? You know? So even though this might be the best way of doing things, it's often hard to actually achieve. Oftentimes people are going to settle for convenience sampling, which is just selecting a sample that is easy, that is available to you, instead of one that is genuinely random, or cluster, which is like if you get like the first 10 people that you find, or stratified, which is a little bit more orderly than that, but still not truly random. So here is an example if we wanted to try to find and why it's important to consider your sample. So let's say this is some real data here that we're looking at Massachusetts, and we find that the mean blood pressure for the diastolic side of that, you got your diastolic and your systolic, or that's backwards, your systolic, which is generally higher than your diastolic blood pressure. Let's say that the mean in Massachusetts is 78. So if it's 78 mmHg, then that's great. But let's say that we picked 10 people at random and we got their blood pressure. So we got those 10 people and we found that the average or the mean is 67. Why? Why is that? It's because we know that people are going to vary individually from that value. And so maybe this group right here is actually a little bit below average. Does that mean that they represent Massachusetts? Maybe a little bit, but they don't really represent all of it, right? And so what we see is that the more people you have in your sample, the more likely it is going to be to represent that population. So the higher the sample, the more representative it usually is of the population. The smaller the sample, the less representative it is. Another way to think about that is that the smaller your sample size, the more likely you are to get errors in your estimate. The larger the sample size, the less likely you are to get those errors. So those individual differences can really skew the data. So let's say that only one person in these 10 people, that one of them has really, really, really low blood pressure, which is called hypotension. And if that's the case, that one person's data may really skew this. Maybe this should have been a mean of 75, but this one person's really low score is going to bring down that total average. So that's why it's really important for us to consider, generally speaking, the more people in your sample, the better. Now, to kind of change gears a little bit, let's talk about mathematical notation. So this, I'm so sorry to say, is something that we're going to need to get used to, because when we start talking about equations, we're going to see a lot of this stuff right here. A lot of these symbols that don't seem to mean anything to us if we haven't had a stats class before. So some of these that I want to focus on, which we're going to be using in some of our earliest equations, are the sum of all values, the total values, and the mathematical average. So let's look at these three things, because you'll see they kind of add on to one another. So if I wanted to express the sum of all values, which means that I want to add all of these values, and these values of x, which means that my data set is going to be x. So if I wanted to sum all of those values, I would represent it like this, where you had this, what looks like a capital E is actually a sigma, which is a Greek character. So sigma x, which means add up all of x. So basically, if you see this on the exam, or if you see this on a quiz, sigma x, it just means that in the data set that's called x, you're just going to add all those values together, and that's going to be your answer. So if x was just 1, 3, and 5, then sigma x would be adding 1 plus 3 plus 5, which is 1 plus 3 is 9, whoops, 1 plus 3 is 4, 4 plus 5 is 9. So that would be how we interpret that. Another way of, another thing that we're going to see is the capital N. So capital N just mean the total number of values. So the total number of values is represented with an uppercase N. So for example, if I said 1, 3, and 5 is my data set, then we would say that the total number of values is equal to 3, because we only have 3 values in the data set. And then finally, if we want to find the mathematical average, we can do that using the tools that we just talked about. So if we're doing a mathematical average, as you may remember, that all we need to do is add up all the values and then divide them by the total number of values. And what that would look like in our little equation right here is the sum of x divided by n. So sigma x, we're going to add 1 plus 3 plus 5 is going to be equal to 9, and then we're going to divide that by n, which is 3, because we have 3 values, which means that my average, my mathematical average, is going to be 3. So here's another example down here. If our test scores for exam number 1 were 90, 100, 80, and 25, sigma x, or sigma exam 1, would be adding all those together, which would give us 295. And if we wanted to say what is the total value of n, then we would just add those values together, which would give us, total values is just how many there are, which would be 4, 1, 2, 3, 4, and then to get the mathematical average, we would just divide 295 by 4, which would be, I'm not going to break out my calculator or try to do it off the top of my head because I know I'm going to get it wrong, and because it has a weird remainder on it, so it doesn't actually divide to a nice whole number, but that would be the mathematical average. So, as I mentioned, there is statistical software that you'll be using this semester, and for us, that is going to be JASP, which you can see right here, kind of doing its thing in this little video. The reason why we're using that is because a lot of times we are going to be using hundreds of data points in our analysis. And so I don't want you to have to analyze hundreds of values by hand. That's cruel and unusual punishment. But instead, we can just load that up into our JASP software and then run it with just dragging and dropping a few values. So some of those analyses can get really hairy. They can be very cumbersome to do by hand. They can take hours and hours to do. Instead, I want us to just kind of know how they're done. We'll work with small data sets by hand, but usually for any kind of realistic data sets, we're going to be using computer software in order to do that. But it's still really important for us to know how to do these things by hand, because that's going to help us understand the theoretical understandings and the theoretical basis and foundation of stats much better. I see all the time people who are really, really good at doing the software side of things, but then they get into trouble because they don't really understand what the test is that they are doing. They don't really understand what their analyses mean. They're really good at crunching the numbers, but not really so good at interpreting what it means, and we want to be good at both, which is why we're going to be doing a combination of doing the stuff by hand, but also doing it with a computer software like this. And I'm going to stop this video here. The next video will pick up and talk about the different types of data. So, yeah, so meet me over in the second video, and I'll talk to you there. Bye.